All right. Thank you all for coming to our second review about our project. The project is still we are assuming we are Airbnb employee, so we are within data science group want to build chatbot or as this the QA bot to customer to utilize this for multiple functions. So we call it a BNBob. So essentially, we want everything. This BNBob actually have all functionality, including to give the answers to the question which customer ask about what kind of knowledge base they have for the Airbnb, such as what kind of the cancel policy, what's the how I can cancel it, or how become a host. So such of that, as well as other functionality that's booking or searching the bookings. And so essentially, this is just a one-stop for everybody. Hopefully, in the future, that automatically somebody can do that. But we are just like try to do the POC for ourselves based on the data we have. So we call it actually, yeah, BNBob. So today's introduction, I thought it's just briefly about frameworks we can introduce. So advanced large language models, we probably briefly talked about before, but we just touch the base a little bit. Then we will talking about existing use cases. I think that's great examples who started to utilize this or is a great example because if they're utilized pretty well, that's going to help us to navigate the industry, new cutting edge technology. Then we will define our scopes of this proof of concept. It's because we are limited by data as well as our engineering abilities. You will see a lot of bugs there. And then we will talk about architectures. So how the chatbots actually a flow chart about how the data flow from the beginning to the end. So from the query to the question, to the answers provided to the users. Then we will talk about a little bit about data, what kind of data we acquire. Then unfortunately, the benchmark, we didn't do anything with it, but I think we have a little discussion last time, which is great because before we just let a vector database search whatever we want, ends up like the price is not exactly what we need or what we want. So we do a little tweak for that, but unfortunately benchmark that haven't done yet. So last we'll go to demo. So first of all, I think it's already touched the last time. Everything a large language models is perfect, right? It's not perfect. It's just like it's so powerful. Everybody can utilize it, and I think it's become really, really convenient, useful, and simple for everyone to use. And I mean, there's not much technological hurdles to ask a question of a large model. The big question is how to utilize this. I think, as I mentioned, there's a couple benefits. Utilize that, not only the well-experienced data scientists, but also the knowledge. So I won't go to detail about that. Then existing use case, I think, to me, I think we need to elaborate a little bit compared to last time. I think today people are much more reliant on their phones, right? So when you see everybody, I mean, on the bus, on the train, whatever they are on the plane, they are looking at the phone. So mostly they conducting their business with the phone as well as their daily lives. So chatbot last message and become really popular, right? For effective communicated between people. I probably now we can connect people with chatbot style message system to what kind of service we want. So especially with the popularity of the GPT grows, people usually ask Google just the keywords. Now we ask the entire sentence. So if they change the behavior toward that, then that's where we try to solve. Just when you ask a question, we give you answers. Not only the answers, give you solutions. Not only the solutions, you backups. So that's essentially we want to do. But ultimately, probably not in this POC. But there's kind of the case, like one example is can Academy have this chatbot? I mean, limited to certain users as well. Priceline has a penny. I think they actually can now see they can book it. So that's I think the one perspective of the use case use large language models for existing cases. So for us, our scope is for Airbnb. It's have the similar goals, right? So the pain point here is make use of this phone-focused app, easy, simple, and provide all the solutions instead of confused. For example, here you see the Airbnb interface look like this. So you have to select the multiple things. So if the person who don't have, which that doesn't have any experience used Airbnb before, he might miss that, right? So what do we want to do in more like this? Either a QA based, we ask the question, we give the answers. Then you can actually link to the answers like listings. Give them you can go to there directly to book, or we can like a conversational based. It's just like a chatbot. You're asking, oh, you actually can talk with them. Some of people might like it, but some of people do. I think it's just like want to do the business quick, as sturdy as quick. So probably won't that. But that's the two options here. So yeah. So what do we want to solve problem here? Okay. So as I mentioned, probably I thought our business case detail a little bit already mentioned before, though that's just like a simple user queries or phrase to answer, not only answer the question, but to have to provide a function and also provide service. So I think this ultimately, this will serve as knowledge base for customer inquiries about policies or other things, as well perform a human-like agent to interact with the customers. I think there's a best benefits for that. As I mentioned before, simple, clear, easy for customer to use with their phones on the go, and all functionality called actually like messaging your friends from the other side. So this time not far away, just behind the screen of the computer. Then this actually, I believe this shortening the development time of just using API calls. And I think if the more and more users get familiar with, or as well as used to the chat-like interactions like ChatGPT, this might be alternatively good user experience. And last but not least, it's like reduce option cost, because every time you actually have the human behind the screen to talk with somebody, charge a lot, right? But especially if you're talking with the legals. But for this case, probably customers much lower, but still you need somebody there. But if you use this one-stop agent, you might be able to just prioritize their human labor work to other things, or reduce workforce, which reduce the cost. And another thing is we were trying to playing with the increase the booking margin, but unfortunately we don't know how to implement this one because we are hurdled by the engineering we have. All right. So essentially, so now we're talking about what are we going to do with this, how we do this. So it's simplify this one. It's just an all-in-one agent architecture. So user has inquiries, then goes to large group model. Large group model actually have some kind of data inputs from the Airbnb service. Then the large model produce output to chatbot. The chatbot could have interaction with customers, right? The customer then goes through the chatbot, interacts with the Airbnb service, such as booking, canceling, make payment, probably become a host, all sorts of things, or ask a question. So essentially, this is a symptomatic architecture we are looking for. Specifically for ours, it's slightly different, because one of the things that we mentioned before, that previous design, we just use the vectorized database to search based on queries, to search the vector database to produce the result. But sometimes, as we know, large language model is not good at math. So when we say, okay, the user want to have a listing between $200 to $300, they might give you $500. So instead of that, we created another way to kind of like filter out those inaccuracies. So let's take a look at this chart. So essentially, if you see the Airbnb listing on the bottom, right? So that's where the first actually help us to build up the filter. So Airbnb listing is going to go to the MySQL database. This SQL database is just sit there, don't do anything until you start to have the user inquiries. Okay, but this one and the help is going to be built to the filter from the top here. Okay, So let me say, let me give you an example. So when the user have inquiries, like ask a question, okay, give me 5 places in Seattle, price ranging to $300 to $500, right? So they have 2 routes. There's first route and on top. So this actually directly vectorize this this inquiry, then go to the vector database to search what kind of listing actually really, have high similarity score to your questions. Then this will stay, then go to a filter here. Just stop here for a second, all right? Then the second route is there. The user inquiry, we can do a little magic called query understanding. So we're parsing out the inquiries. So, okay, find the location, that's in Seattle. Find the price range, 200 to 300. So that then we formulate a SQL query to go through my query database. Then this result is going to be screen out like a if based on the so search location, then search the price range, probably get, based on the what kind of price range you have. Sometimes give you 200, sometimes give you 3,000. Then you check whether or not the vector database results and the SQL database results have overlaps. If have the overlaps, they can send it to the large language model to generate the answers for you. So that's essentially our pipeline here, because the rest of it is pretty easy. It's embedding. Any questions so far?
No.
Okay. All right. So this is our general pipeline to how to framework this POC architecture. Then after this, we just load a bunch of the Excel files, mostly just based on, you see the yeah, we have 108 CSV file, but I think I mentioned here is a 108 location. Probably it's not accurate. I checked it as if you take a look at neighborhoods, actually have 70,000 and for locations, but if just based on cities, probably 200 something. But anyway, then default we just use the listing. I mean, we haven't used the reviews. Yeah, and then listing have those kind of columns. You can take a look at it. Then yeah, then our data for now is just I built one for Washington DC, one for Seattle, and I try to merge the the vector database, but it doesn't work. I don't know where the codes have some error, but anyway, so this is the one. Yeah. So as I mentioned before, unfortunately, we didn't do as many benchmarks. I think that's going to be the future if we continue this as a journey. So here we go. This is the demo. This demo going to be slightly different. This is the more conversational based chatbot, conversational chatbot demo. Yeah. So you can actually, we have the multiple routes to the different prompts based on the question you ask. Then you can actually just call them or just have a basic conversation with them. I think the model is behind this GPT 3.5 Turbo dash 16K, which have token limits, I think, up to 18,000, if I remember correctly. But anyway, so this is actually so it's a multifunctional, but since we only have this listing information from the Airbnb, if we have the knowledge base of BNB, definitely the prompt can be routed to that rack to retrieve the information from there. So unfortunately, as Kailash mentioned before, that is our infrastructure is not great as those enterprise, so it's going to take a while to run. But still much faster because I'm running on my servers. It's still much faster run on computer, but still take a lot of time. Yeah, so let's just finish. So let's give you a sense what exactly look at. Then I can demo in real time, but you will see lots of interesting happens. I think that's it. Yeah, I think that's a similar thing. Unfortunately, the URL cannot be rendered in the chat, but hopefully we can improve that in the future. So that's all for my presentation. So, oh,